Hello, Algebra 2 students. Taking a look at what you have here for Monday on the 19th. We're looking at, if you're online, you may be looking at this a little bit later, but the week of the 19th, I guess I should say. Well, I'm looking at the 2-2 practice, direct variation. And it says, for each function, determine whether y varies directly with x. If so, find the constant of variation and write the function rule. I actually have, I don't know why mine didn't print out, but let me rewrite what should be here. I should have -6, -2, 9, 3, 21, and 7. I think your papers should have them. For some reason, mine didn't work out. But so what all I'm doing is, I'm taking that the y over 2, see if it's constant, see if it's a constant of variation. If it's the same thing every time I divide, my y over x value. And you'll find that when you do this, -2 divided by -6, 3 divided by 9, 7 divided by 21, you get a, you get a 1/3. So you should say yes with this one. And it is 1/3. And the function rule would be y equals 1/3 x. Okay? I'm kind of writing small, squeezing it in there. Try 2 on your own. And 2, you should be getting one. This one should be a yes, but just figure out when you take y divided by that, do the first one and you'll figure it out. This one, 56 divided by 7, 22 divided by 11, 56 divided by 7, you get 8, 22 divided by 11, you get 2, all different. 2, so no. This one does not have a constant of variation. Okay, going on to this group of problems here. Determine whether y varies directly with x, and if so, find the constant of variation. So, taking a look at number 5, you would say this is written in that, that way that we talked about last week, y equals kx. And we're looking if it's written like this, if we could get y by itself on one side and for it to look like this. So yes, this one does. So we have number 5, we have a yes, and the constant of variation is -1.2. This right here. Okay, that's our k, the constant of variation. This one, when I work this out, you'll end up with y equals 3x plus 1. This little addition onto this does not make it look like an equation like this. So you are going to say no, this is not a constant of variation. It does not vary directly. Y does not vary directly. Try it on your own, 9, and hopefully you're pausing this as you go along the way. This one, if I was to get y by itself, I end up with x minus 2. This back here, no, I can't be adding or subtracting anything from k. I can only be multiplying by k, get a slope. In other words, remember, this is your y-intercept. This is not going through the origin on a graph, so it's not a direct variation, so no. Okay? Taking a look at these, it says y varies directly with x, so you have to, knowing that, you have to figure out what they are asking for here. Let me see. So number 11, if y equals -14 when x equals -7, find x when y equals 22. So you would just divide this and you get 2. So 22 divided by 2 is 11. Okay? So remember, you're just like you did up top, you take y divided by x. Try 10 and 12 your own on your own, and then 13 we'll do this one together. If y equals 4 when x equals 14, find y when x is negative 5. So in that problem, we are going to take y divided by x, so 4 divided by 14, and I get a really ugly number, 0.28 whatever. So it would just be, 4 divided by 14. So on my calculator, I could actually, just take that as a fraction, 4 divided by 14. So I take 4 divided by 14 instead of trying to put this, huge ugly number in there. 4 divided by 14 and multiply it by my x, which is my negative 5. And let me go back and just put that in parentheses just so it keeps everything nice and neat. And I get that ugly number, which actually is, I'll just make it into a fraction for you. Negative 10 over 7, so that number's right there, negative 10 over 7. Let me do negative 10 divided by 7, and I get that ugly number too. So I would rather write it as a fraction than this ugly number here. All right. Taking a look at 15. The amount of lemon juice in a lemonade recipe varies directly with the amount of water. And the recipe calls for 8 ounces of lemon juice and 32 ounces of water. So how much lemon juice should you use if you start with 28 ounces of water? So that 32 to 8, that 32 to 8 gives me a 4, okay? So if I take my 28 and divide that by 4, that's going to give me 7 ounces. Okay, so your answer for that one should be 7 ounces for your direct variation for number 15. All right. For these, I just want to give you some stuff here. For 16, you could watch 17 and then go back and do 16. But all you're doing is you're taking some x values, some y values, and says to make a table and then to graph it. And so let's go with I'm going to start with -2, -1, 0, and 1. And what I'm going to do is I'm just plugging in this x value. So I have 2 cubed times the quantity of -2. And I'm just picking these because this is kind of centered the most on your, if you were to graph this. And then you could actually graph these, and you should graph these in class with some graph paper, or you could, quickly kind of draw up a messy graph, but you could get it on there on notebook paper if you need to. And so these are the numbers that you should be getting. Remember, you should be going through the origin at some point because this is a direct variation. Let me give you some numbers that you could graph over here. Well, let me not do that. I won't do that because you could come up with your own numbers if you want to go with your x value. Let me write this out. If you want to go with these numbers, go ahead. I have 5, 10, 15, and 20, and then see what you get when you take 1/5 of 5, you get 1/5 of 10, you get, that makes these numbers on this side easy, I guess. Okay, we are to write and graph a direct variation equation that passes through each point. And the way that you are going to do that is you're just going to find that you know that these are direct variations. So you're going to take that y divided by the x. So every time you take y divided by x, so this would be the 9 divided by the negative 1.5. When you do that on your calculator, you will get that negative 6. So I plug that back into my, this, y equals kx. So I plug that back in. So this 9 divided by negative 1.5, you'll get 6. So negative 6x. So that's my new equation there. 21, when I take 3 divided by 7, I just get 3 7ths. Might as well keep it easy. So 3 divided by 7 looks like that. So I go ahead and plug it in to make my my equation there for direct variation. 23, this is kind of complicated, but you're going to take that negative 7 over 2 divided by 3 over 5. What you get is negative 35/6. So you should get y equals negative 35 over 6x. The way I did it, once again, is I took the y, this value, negative 7/2, divided by 3/5, and you could do that in your calculator and get that same answer. And then number 25, you're going to take 165 divided by 3, you get 55. That's 165 divided by 3 equals 55. Go ahead and plug that into your equation as your slope, 55x. There you go. Go ahead and try the rest of them on your own and try to solve. There's just a couple more here, and see how you do on those using what you have learned and practiced last week and on this direct variation 2.2 practice worksheet also. Good luck.